Welcome to video lesson number 22. This is on inequalities. For this video lesson, you will of course need the video lesson notes you were given in class, TOC 22. You will need a pencil or pen to take notes, a highlighter, marker, or colored pencil, and calculators are permitted for this unit. All right, for inequalities, these are very similar to equations, but they're slightly different. So instead of having an equal sign, inequalities have an inequality symbol. So the three parts to an inequality is that you have a variable, just like an equation has. Of course, that's any letter that stands in for an unknown value. And then you have the equality symbol, which can be one of four types. You have either less than, greater than, less than or equal to, or greater than or equal to. And then you have a number, and that's any positive or negative number. If you need more time to write this stuff down, pause the video. And like I said, inequalities are just like equations, but the difference is they have multiple solutions or multiple answers. Equations only have one solution, meaning x is that number. Inequalities, we would say x is greater than 5, which means x is any number that's bigger than 5. So it could be 6, it could be 7, it could be 8, it could be a million, but it's any number that's bigger than 5. So that's the difference between an inequality and an equation. So here are some examples, and go ahead and write these in the box that's in the middle of your page, and then I'm going to explain how you read them and what they mean. So the first one is read as F is greater than or equal to -3. And that some answers that could be equal to that is, of course, -3. But since it's greater than or equal to, that could be -2, -1, 0, 1, 2, anything that's bigger than -3. So it could be 5, it could be 10, it could be anything that's bigger. As long as it's bigger than -3 or equal to -3, it works. So if you look at the second example, now this one's a little bit different because it's backwards. It's saying -7 is greater than y. But if I flip it around and I read it from the variable, and you have to be able to do this both ways, you can think about it backwards. It'd be y is less than -7. So y is less than -7. So the answer is less than -7. So it's any number that's less than -7. So that would be -8, -9, -10, -11. Notice with this one, -7 is not included in the solution because there's no equal sign, there's no bar underneath it. Looking at the third one, h is less than or equal to 19. So it's any number that's less than or equal to 19. So 19 is included in the solution, but it's less than 19. So it's 19 or anything smaller, like 18, 17, 16, 15, 0, 1, anything that's negative. Okay, and the last one, x is greater than -6. So anything that's greater than -6 could be 0, could be 5, could be 10. Oops, I put in that -6 is included. -6 is not included in that solution. So again, you don't have to write all that, but you do have to write in those examples in the middle, but we're going to be talking more about that in class. Okay, so graphing an inequality. So some things you have to know. You have to know how to read an inequality. You have to know how to graph an inequality. You have to know how to solve addition and subtraction inequalities, just like you had to know how to solve adding and subtracting equations. And you have to know how to translate and think about words with inequalities, and we're going to teach you all that in class. So if we look at the first one, that is a greater than symbol. And we know because the greater than symbol is pointing, he's going to eat what's greater on the left. And that would be an open circle because there's nothing underneath. There's no equal sign underneath. And so it'd be an open circle, and greater goes to the right because it's all the numbers that are bigger. So you do need to write and draw these arrows with this on your paper. The other example, the next example, is less than. So because the less than is to the left, so write less than. And again, it's an open circle because it's not including the number. So it's an open circle, meaning the number that I'm using with my variable is not included in my solution. And it's all the numbers that are less than that number. My third number, notice this one has it's part of an equal sign and it's the less than and greater than sign. So because it has part of the equal sign, it's greater than or equal to. And because it is part of the equal sign, it also includes the number as part of the solution. And so because it includes the number, instead of using an open circle, we use a closed circle to show that that number is part of the solution. And so we draw a closed circle, and the arrow goes to the right because it's all the numbers greater. And then the last one is just like the second one, but again, since it's an equal sign, it has that line underneath it, we are going to draw a closed circle because it includes that number that is included with the variable. And we're going to show you this in class so it makes a little bit more sense. But go ahead and write this in your notes, and it'll make more sense when we put some numbers and letters with it. And we always read inequalities from the variable. We're going to teach you to write them always both ways so you don't get confused, but always reading inequalities from the variable. That's the letter. Remember, the variable is the letter. Okay, so if we look at this example, we have an open circle. That means that when we see our inequality symbol, there will be no line underneath it. So in this case, I'm going to use X for my variable because that's what my direction says. X is going to be greater because I'm going to the right. It's greater than, and where my variable or my circle is, that's my number that I use. So X is greater than 2. The solution shows the numbers that are bigger or greater than 2. The open circle means that 2 is not included in the solution. So I start with my variable on the left, which is X. X is greater than 2, or if I were to turn it around and write it the other way, 2 is less than X. So all I did was I switched my symbol around and I rewrote it so that 2 is less than X. So X is greater than 2 because my arrow's going to the right, or you just turn your arrow going the opposite direction and put your number first. So you do have to be able to write your inequality statements both ways, and you have to be able to read them both ways, but always try to read them with the variable from the variable just so it's less confusing. So here's another example. With this one, notice that you have a closed circle, so -3 would be part of your solution. Again, it's going to the right, so it's greater than, but we would say greater than or equal to. So the solution shows the numbers are bigger or greater than -3, and the filled in closed circle means that -3 is included in the solution. So I would start with my X. X would be greater than or equal to -3, and we want you to be able to write both ways, so then we would flip everything around and start with -3, flip your inequality symbol instead of greater than. It would become less than or equal to, and put your x second. And again, we'll be going over this in class, so it will become a little bit more clear. Here's another example. This time, my circle's at 0, so that's going to be my number. So it's going to the left, which is less. So the solution shows the numbers are smaller or less than 0. It's an open circle, so that means it's not included in the solution. I will not put a line underneath my symbol. So x is going to be less than 0, or 0 is greater than x. My last example on the front page. I have a closed circle at 4, so I'm going to use x and 4. And since it's a closed circle, I'm going to include that line underneath. And since the solution shows that the numbers are smaller, less is to the left than 4, the filled in closed circle means that 4 is included in my solution. So x is less than or equal to 4. And then we're going to switch everything around, put 4 first, and say 4 is greater than or equal to x. Okay, do me a favor, flip your paper over, and we're going to talk about how to solve them. Now, the good news is solving inequalities is the exact same as solving equations for adding and subtracting. And that's all you have to do in 6th grade. So the good news is you use the inverse operation to get the variable alone, just like we did for equations. Don't forget to check your answer just like you did for equations. It's the same exact thing. So for addition, you use subtraction. For subtraction, you use addition. Same thing. It's nothing new. However, the only difference is instead of one solution, you're going to have many different answers. And instead of getting x is equal to this, you're not going to have an equal sign at the end. You're going to have one of those inequality symbols, and you're going to be graphing it on a number line. So, of course, at the end, you have to figure out which way does my number line go. And so an easy way to do that is when you're done, plug in 0 for your variable to figure out which way does your inequality line need to go? Which way does your graph need to go? That's just an easy way to, and I'll show you what I mean by that in just a minute. Your arrow is going to point to 0 only if 0 makes your inequality true. So let's solve this one and I'll show you what I mean. So just like if we were to pretend that was an equal sign, it's not. Don't get into the habit, because if you write an equal sign, it will be marked wrong. But solve it like it was an equal sign. This is -3. I'm going to solve using addition. So add 3 to both sides, just like it was an equation. The -3 and the +3 cancel each other out. I end up with just x on that side. X is greater than -2. So, get in the habit of writing it both ways. Same thing we just did on the front side. Now, since it's got no line underneath it, I know it's going to be an open circle at -2. I can go ahead and draw that. But now I have to say, which way is my arrow going to go? Plug in 0 for x to see, does 0 make the inequality true? Is 0 greater than -2? Is 0 bigger than -2? Yeah, 0 is bigger than -2. So then guess what? That's the way your arrow goes. So then I know that because x is bigger than -2, my arrow goes to the right. And so then you know that your arrow is going that way. That's just another way that you can tell which way your arrow goes without having to know greater, less, that kind of thing. Just another way to think through with your inequalities. Okay, so let's try the second one. This one's an addition inequality, so we're going to solve it using subtraction. Okay, so subtract 5 from both sides. The 5's cancel on the left. We get -4 on the right. Do not write an equal sign. Get used to writing it on both ways. Now, open circle at -4, because I don't have a line at the end underneath. Which way does the arrow go? Plug in 0 for B. Does it make it true? Is 0 less than -4? No, it's not. So I'm not going to include 0 in my arrow. It's going to go the opposite way. So I know which way my arrow goes. It does not include 0, it goes the other way. So that's how you know which way your arrow goes. So that's how easy solving and graphing inequalities is. And now it's time for you to show what you know. Log in and take that homework quiz.